This is DSC 1520. Today I'm going to be looking at assignment 1, which is one of the compulsory assignments that you need to do to submit before the actual due date. The due date for the assignment is the 6th of March, so please make sure you do submit it before the deadline. The first assignment is multiple choice. Question number 1 looks at a line cutting the x-axis at 4 and goes to the point 2 and 4. So if I'm looking at a line that cuts the x-axis, that gives me an x-intercept, so that'll be 4 and 0. I then have another point here, 2 and 4, and I'm looking for the equation of a straight line, which is y equals mx plus c. The first step is to get the m, which you guys should know is y2 minus y1 over x2 minus x1. The c is representing the y-intercept. So now I'm going to substitute points into m, okay, to work out the m, then work out the c, and then I'll have the equation y equals mx plus c. So to show you the working, those are the 2 points. If I substitute those values into the equation to work out m, I get an m of minus 2. If I then substitute minus 2 in the y equals mx plus c using one of the points, okay, the point that I used here was 2 and 4, all right, to solve for point c, or for variable c. And that's how you would calculate the c. You get 8. So the final answer is obviously your minus 2 here, which is your m. Your c is 8, so y equals minus 2x plus 8 is the answer for question number 1. Question number 2. A market is defined by the following demand and supply functions. Right, so you've got demand and you've got supply. If they want you to find equilibrium, I need to make demand equal supply, and then I need to solve for the missing variables. Okay, so if I substitute those amounts into, if I make that equal to that, and I substitute the amounts in, I'm going to get the two equations being equal, and then I can solve for the missing amount. Okay, so if I show you the working for that one, make the two equations equal, take the q's to the one side, take the numbers to the other side, and solve for q. You get q as 8. Then I need to solve for p. Substitute in. So I've got the q of 8. If I substitute the q of 8 into the other formula, I then get p. So I've used this equation, p equals 50 minus 3q. I've substituted 8 in, and I get 26 as p. So q is 8 and p is 26. P is 8 and q is 26. Let's just go back and see. Q is 8. Okay, q is 8 and p is 26. Q is 8 and p is 26. So it would be that one. Now we're looking at questions 3 and 4. They're based on the following information. They've given you a demand function for a commodity. There's the demand function. P equals 215 minus 5q, where P and Q is the price and quantity. They want to know, determine the point price elasticity of demand. Right, so when looking at point price elasticity of demand, we spoke about that as being P over P minus A. Okay, there's a formula that you need to remember in your working, and obviously P here is 15. Okay, so the 215 represents the A, the 15 represents the P. If I substitute all of that into the equation, I then get an answer for it. Okay, so I've given a page reference here for any of you who want to maybe refer to the textbook. The textbook gives you a note there about the point price elasticity of demand. It's P over P minus A. If I substitute the 15 and the 215, I get an answer of negative 0.75, which you can convert back to a fraction, which is negative 3,40. Okay, 3 over 40, negative 3 over 40. Question 4 is using the same information. They say which of the following statements is true. All right, this is a theory question. We know that minus 3 over 40 is the point price elasticity of demand. Okay, so when you see that notation here, Okay, when you see that notation as a box, if I put a number here, it always makes that number positive because that's a representation of absolute values. Okay, so they're saying the absolute value, okay, so that line of the point price elasticity of demand is equal to what? Okay, well, obviously, if it's absolute value, it'll be a positive. And the positive is less than 1, so demand would be seen as being inelastic. Okay, so I would be going with question 3 there, or option 3 rather, for this question, based on theory. Right? We're not going to get too much into the economics. Remember, this is the math that they're testing, not the economics. Obviously, in the assignment, they're testing a bit of the theory from the textbook, and that's why you see a bit more of it here than you would in some of the past papers. So do go through the material, so at least you're comfortable with it. For those of you that are studying economics as well, you'll probably have a slight advantage to those students who aren't studying economics at the moment, because you would have covered more of the theory in economics specifically. Question 5. What is the point of intersection? So again, a different way of testing a simultaneous equation. You've got two formulas here. You're going to then substitute or eliminate to try work out x and y. So you could do this, make y the subject here, minus 2x, and then I could take the y and I could substitute that into that equation to solve for my x. So once I've got my x, I can then substitute back in order to calculate my y. So if you've done that correctly, you're going to get an equation that looks like this. Right, I made the one equation the subject of the formula. Okay, so there's y equals 5 minus 2x. I then took that and I substituted that into the equation, and I got 4x plus 3y minus 2x, close brackets, equals 11. If I then substitute and solve, and I eliminate and I look for the x, I eliminated the y, I then get an answer of x equals 2. If x equals 2, I then have to substitute back into the equation. Any equation with y, I use that one to solve for y. X was 2, so if I put x in there, I'm going to get 4. So 5 minus 4 is 1. So x is 2 and y is 1. Questions 6 and 7. We're basing everything on those two supply functions, well, supply and demand. Okay, there's the demand, there's the supply. What do they want to know? They want to know what the consumer surplus is. All right, so think about this. Consumers do what? They demand goods and services. So with the consumer surplus question, you're actually looking at the demand function. The demand function is going to be sloping in that direction. This is theory that they've covered in the textbook. Again, just to give you guys a summary of what's happening, demand slopes down, supply slopes up. So if I've got demand and supply, I'm going to have equilibrium at some point in time. We want to know the price and the consumer surplus at equilibrium. So the first step is obviously to work out what is the actual equilibrium price. Once we've got that, we can then work out the consumer surplus. Consumer surplus is going to be this area under the graph, okay, the demand graph. That's what you're looking at. So you're looking at half base times height. Area is half times base times height. So in order to calculate the consumer surplus, I need to first work out the point of equilibrium. So to do that working, I've made the one equation equal the other. Okay, so there's the two equations, the one equals the other. Take the q's to the one side, take the numbers to the other side, and I solve for q. I get q as 20. So price and quantity is 20. Okay, so while q is what I've just worked out, 20, I still need to work out the p, which is the price. If I'm looking at demand, there's the demand function. You know that 255 would be the point over here because that's the y-intercept. So 255 is the y-intercept for that graph. Remember, it's where the line cuts the y-axis. Then I'm focusing on this, which is the price. So if I'm trying to work out the price, I've already got the quantity. I can substitute 20 into the equation to get the p. So if I do that for you, there's it there. P equals what? 175. So now if I plot that onto my diagram, 175 is this point over there. Now I've got 255 and 175. I know what those 2 points are. Can I work out this in terms of the actual distance between that point and that point? Yes, because that'll give me the height. Okay, the height is how high you have in terms of that point to that point. In terms of the base, I know what the base is because that's 0. The base would be 20, okay, because that's the quantity. Remember, price is generally denoted on the y-axis and quantity on the x-axis. It doesn't matter how you do the graph, you'll get to the same answer eventually. So that's the way I've done it in terms of the graph. If I then substitute those variables into the actual formula for the surplus, which is that. Okay, so looking at this, so far I've already got the price. I'm happy with point number 4. Let's check the surplus if we get 800. Here's the working. Half base times height, substitute the base, substitute the distance, okay, the height, which is obviously the difference between the 2 points. And if I work that out on the calculator, I do get 800. And that is the area which is representative of the consumer surplus. Question 7. If tax of R11.50 is imposed on the product, then the equilibrium price and quantity will do what? Okay, what's going to happen to those 2 things if a tax is imposed? So if we're imposing a tax, again, it's theory, right? We're going to be looking at those equations, right? So I've got demand here and I've got supply. Obviously, if a tax is going to be added to that particular situation, it's going to affect this formula. So adjust for the tax. Again, there's a page reference here if you guys want to do some additional reading in the textbook. On page 121, they discuss the different types of taxes or subsidies you can get. And there is an example there as well relating to the supply where you're providing for the tax. So what is that going to do to my supply? It's going to reduce the supply by R11.50. If I then solve, I get a new PS, which is the price, okay, price demanded, price supplied, and I then need to work out the point of equilibrium. So if I substitute the new formula, which is that one, okay, into the equation here, okay, still equal to PD, so PD equals PS. We don't change that. Okay, we know price demanded and price supplied needs to be the same. I'm just obviously altering the one formula before calculating a missing amount. If you solve for Q, you get 19. After having solved for Q, you substitute into one of the equations to calculate P. So I used that equation to calculate P, substituting the answer of 19 in there, and that gave me 179. So Q is 19 and P is 179. Question 8. Lighting warehouse produces Q solar lamps per week at a fixed cost. So there's fixed cost, that's important. Each lamp costs 150 to produce. So that is a variable cost. Remember, total cost equal fixed cost plus variable cost. That gives you the total cost. And they're sold for that, 350. They want to know their total cost and the profit functions. Okay, so total cost, there's the formula we just need to substitute in. And then profit, well, to calculate profit, I need total revenue minus total cost. Total revenue is going to be price times quantity. Okay, so I need that in order to work out the total revenue. In the question, it told you that each item will be sold for 350. So I have a price of 350. So 350 times Q minus the total cost function, which we'll look at now because we need to establish what that is. Okay, and that will give you the profit. Profit will be the total revenue minus the total cost. So if you do a working for it, let me show you what the working would look like. Total cost, fixed plus variable. Okay, so if I add up, I get that. Okay, the fixed plus the variable. I know what total revenue, it's that. Profit is total revenue minus total costs. So this minus that. The profit function I come out to is the 200Q minus 10,000. That's the profit function. Okay, so 200Q minus 10,000 is the profit function. Okay, so there's 200Q minus 10,000, which is the profit function. And we had total cost here, which was 150Q plus 10,000, which is what we have there. Okay, so number 1 is correct. Question 19. Consider the following set of inequalities. Okay, so here you've been given 1, 2, 3, 4 different inequalities, and we need to look at the correct representation, okay, of the feasible region. So where do all those inequalities satisfy in terms of their graphs? Okay, so the most easy ones that you should always look for is this one. Okay, x and y must be positive, okay, greater than 0. So if I'm looking at x and y, alright, so x must be greater than 0, so it must be on that side. Y must be greater than 0, so it must be on that side. Here's a feasible region that's shaded on that side, which is negative, so number 1 is out. Okay, here I'm looking at that side, and I'm looking above there, so that's a possibility. Here I'm looking that direction, and I'm looking in that direction, that's a possibility. Here I'm looking at that direction, and that direction, also a possibility. Right, so when looking at a system of equations here, you need to do a test. You need to test on the left or the right of the actual graphs. So when I go back, I'm going to look at a line, and the line that I've got here for number 1 is labeled on the actual graph. Okay, so there's there. Okay, so where's my line 1? Here's line 1 in this equation. Okay, so let's focus on that line. Then what do? I choose a point on the left and the right of that particular line, because that's the graph. Okay, so the easiest point is always to choose is 0, 0. Okay, so if I put 0 into that equation, 0 plus 0 gives me 0 plus 0 gives me 0. So is 0 less than or equal to 13? That's true. Okay, so if I'm looking at graph 1, I would be looking at everything on this side of the graph, okay, of the line, because that makes the line true. So that section there is on the other side. This is also out. Let's go back and let's look at these. Okay, are we looking at this side of the line? Yes. Are we looking at this side of the line? Yes. Okay, so I'm happy with that as being a possible answer. Same thing here. There's line 1. I'm looking at this side of the line, and I'm looking at that side of the line because we tested the point of origin. Okay, go back, look at another line. So now I'm going to be looking at line number 2. Okay, so line number 2, where is line number 2? Let's highlight it. There's line number 2. Okay, so if I'm looking at this graph, I'm going to look at a point on this side, and I'm going to look at a point on this side. So easiest point is always the point of origin. Okay, there's the point. Right, so let's put in a 0. Okay, so if I put in a 0 here, I'll have 2 times 0 minus 0 less than or equal to 8. 2 times 0 is 0, minus 0 is less than or equal to 8. Well, 0 minus 0 is 0. Is 0 less than 8? Yes, so that's true. Okay, so I'm definitely looking at that side of the line, okay, that side of that line, okay, which is that feasible region. Right, looking at this graph, there's line number 2. It's not looking at this side, it's looking at the opposite side. So point number 4 is out. Point number 3 is correct. 3 is the correct answer because you're looking at where does everything intersect. Test points, use the origin because it's easy to substitute. And then my final answer here was 3. Question 3's answer, option 3. Question 9, sorry. Question 9's answer is option 3. 10, guys. We're looking at a small ironworks manufactures 2 types of gates. Okay, the time requirements in hours for each stage of the production, the limitations on the available labor hours, okay, and the selling price per unit are given in the following tables. Okay, so we've got selling price, we've got the stages of production, the gate type, so we've got welding, okay, or finishing. We've got security ornamental, that's the type of gate. Obviously, we look at the source, the source of or the stage of production. Okay, how much does it require, and how much hours is available. Right. So the table really helps a lot because they've given you everything in that particular table. So if the number of security and ornamental gates to be manufactured are denoted by X and Y. Okay, so X is the ornamental gates. Hey, no, number of security denoted by X and Y respectively. Okay, so security is X. And ornamental is Y. Okay, so now in terms of welding, I'll have 4.5x and Y I'll have X there, and I'll have Y there. Okay, the selling price would be X here and Y there. Right, what do they want? They want to know, respectively, okay, then the objective function and the constraints are. Okay, so they want to know what are all the different systems of inequalities here. Okay, so the first bit is I need to look at each stage. Do you agree the welding stage, okay, is limited to 900 hours? That means, okay, in terms of welding, if I'm looking at ornamental, okay, the ornamental is denoted by Y, okay, and security is denoted by X. So obviously 4.5x plus 2y must be less than or equal to 900 because it must be within that particular time frame. Okay, so let's write that down. Welding. Okay, how many hours do you have available? The question said it's 900 hours. Okay, so 4.5 plus 2. 4.5x plus 2y must be less than or equal to 900. Okay, that's your first equation. All right, so 4.5x plus 2y less than or equal to 900, that's a possibility. Plus 2y less than 100, that's a possibility. Plus 2y greater than, that one's out. Okay, so number 3 is out. Okay, 4.5y plus 2y less than or equal to 90, that's a possibility. Okay, then with the finishing, same thing applies here. Okay, so now you've got 1x, which is x, plus 2y must be less than or equal to 400 hours because that's the finishing. Right, so you can't use more than 400 hours there. Right, so x plus 2y less than or equal to 400, that's fine. X plus 2y less than or equal to 400, that's fine. X plus 2y less than or equal to 400, that's also fine. Great. Okay, and then we're going to be looking at, well, the selling price, okay, which is 7,200. Okay, they want to know what the objective function is. Okay, so maximize total revenue. Okay, maximize total revenue. Okay, so let's work out what total revenue would be. Okay, TR, total revenue, would be price times quantity for the one good plus price times quantity for the other good. Okay, so if I'm selling security gates, total revenue would be 7200x, okay, plus 665y. Okay, that's what we're looking at here in terms of the actual equation. Okay, so 7200x, okay, plus 665y. Okay, so maximize TR equals 720x plus 665y. That's good. Okay, that's great there. Right, this one, 7200x plus 665y. Okay, this is looking at profit. That symbol is representing profit. When you see that pi symbol, it's just a lazy way of writing the word profit. That's what they mean when you see that profit sign. Okay, so that wouldn't be correct. So that will be out. Okay, so 4 is out. 1 is out. So now we're choosing between 2 and 5. Okay, do we have this? Yes, because x and y denote what? Obviously, the number of security gates. So can I have a negative amount of security gates? No. Right, it's either you have security gates or you don't. So they need to be positive. So both x and y, i.e. the gates, okay, in terms of quantity, need to be given as a positive value. Okay, so 2 is the correct answer for this one. Question 11. The supply function of a certain product is that where P is the price and Q is the number of units produced. Determine the producer surplus if the market price is 200. Okay, so earlier we looked at what? Consumer surplus. Here we're looking at producer surplus. Okay, so now I'm going to be drawing the graph again. Okay, and the graph slopes upwards because that is supply. Okay, so we're looking at the surplus. Okay, the area under the graph. Okay, the supply function for a certain product is given as that, where P is the price and Q is the quantity. Okay, they tell us what the market price is. Okay, so market price is 200. Determine the producer surplus if the market price is 200. Okay, so if P is 200, P equals 200. What would Q be equal to? Well, we need to substitute that into that equation. So 200 equals 80 plus 5Q. Okay, then I'll have 200 less 80, which is 120, equals 5Q. Right, if I solve for Q, 120 divided by 5 gives me 24. Okay, so Q equals 24 and P equals 200. This is the supply function. Okay, so obviously, the graph I need to draw needs to start somewhere else, not down here at the bottom. Sorry, I drew it at the point of origin. That's not quite correct. Okay, because you're looking at this equation. Price equals 80 plus 5Q. 80 plus 5Q. So 80 is that point. Okay, going up. That's the supply function. Right, so that's 80. Okay, we just worked out a point, which was what? P equals 200. So P equals 200. So that's the 200 there. Okay. All right, and that gave us a Q of 24. 24. Right, so if I'm looking at producer surplus, I'm looking at this area under the graph again. Okay, so again, it's going to be half base times height. Okay, so area equals half times the base times the height. Okay, so it's half. The base is 24. Okay, there's the base, 24. Right, and the height will be the distance between those two. Okay, so 200 minus 80 is times 120. Okay, so if I times it out, it'll be 24 times 120 divided by 2 or times a half gives me 144. Okay, 0. Right, option number 2. Producer price surplus is the area under the graph. That's all it is. Okay, so plot, draw a little sketch, get the values, then substitute and solve. So question 11's answer would be 2. Okay, area under the graph, that's key. Right, find points and use area equals half times base times height. Okay, and there's the working. We looked at it here. Right, question number 12. I'm just going to erase a little bit of the top bit here so you can read that section over there. Okay, it costs R2.50 to print a paper book and it costs R1 to bind each book. Printing and binding setup costs are 1,000. These paperback books are sold to retailers at that price each. Find the number of paperback books that must be printed, bound, and sold to break even. Okay, so where do I break even? I break even where total revenue equals total cost. That's where I break even. So my units here, where is the units? Do they give you units? No, they don't. They just give you costs. All right, so we'll assume that the number of books is X. Okay, that's the books. All right, so if I'm looking at total revenue, these paperback books are sold to retailers for R4.50 each. So total revenue will be R4.75 X will equal the total cost. So it costs R2.50 to print a paperback book and it costs R1 to bind each book. So here we've got the printing and we've got the binding. And then they say printing and binding setup costs are 1,000. So to set up the printing and the binding, I need an additional 1,000. Okay, so 2,5, which is the printing, then plus 1x, which is the binding, plus 1,000, which is the fixed cost to set up. Okay, and there's the equation. And what am I solving for? I'm solving for x. Okay, so take the x's to the one side and the numbers to the other side. Okay, so 4.75 minus 2.5 gives me 225 x. Okay, plus 1. Don't forget the 1 there. So minus another 1. I'll get 1.25. Okay, so 4.75 minus 2.5 minus 1. Okay, so minus 3.5 gives me 1.25 equals 1,000. Right, so 1,000 divided by that answer gives me 800 books. So that's the number of books that I would have to sell in order to break even. Okay, break even is total cost equals total revenue. Answer to question 12, number 3. Break even, total revenue equals total costs. Okay, price times quantity equals fixed plus variable costs. Right, and then you're literally substituting and solving. Okay, the answer that we get here is 800. Question 13. Consider the following graph showing the demand and supply functions of a certain good. Which one of the statements below is true? Okay, so point A represents the break-even point. Well, point A doesn't represent the break-even point, that represents equilibrium. Okay, line 1 represents the supply function. Line 1 is the supply, well that would be true supply is upward sloping. And line 2 represents demand, demand would be downward sloping. Point B represents the minimum price consumers will pay. There's the minimum price, no. Minimum price that consumers would pay would be there. Okay, the demand, okay, would be nothing. Okay, they wouldn't want to pay anything if they wanted to get goods. Okay, that would be the minimum. Right, the area of triangle ABC represents the consumer surplus. A, B, C, no. Consumer surplus would be that. Okay, that would be the consumer surplus. That's also wrong. So wrong, wrong, wrong. None of the above, no. Line 2 would be correct. Okay, supply is upward, demand is downward. Okay, so question 13, 2. Question 13, option 2. Great. Question 14, guys, we're looking at residents at a retirement village have the option to eat lunch at a central lounge. When the price per lunch is 45, there is demand for 80 lunches. It is known that for each 1 rand increase in price, demand increases by 2 lunches. Okay, find the demand function with quantity Q as a function of price. Okay, so that's pretty easy because we're looking at the actual demand and supply. Okay, we need to identify the different variables. Okay, so residents at a, okay, so we've got that. Okay, when the price per lunch is 45, so P equals 45. All right, there is demand for 80 lunches. Then quantity is 80. That's what we've got. It is known that for each 1 rand increase in price, demand decreases by 2 lunches. Okay, so every 1 rand increase in price will lead to quantity, okay, decreasing by 2. Okay, so 1, okay, increase in price declines it by 2. Find the demand function with quantity Q as a function of price P. Okay, so we need to establish what this is. That's a point. Okay, remember, I need y equals mx plus c. Okay, so there's the point. Obviously, I'm going to have to interpret this. So y we said is denoted by p, and x is generally denoted by q. Okay, so q, quantity is 80, and price is 45. Okay, then that'll be like your x and your y. Okay, so they're looking at this, change in p over change in q. Okay, so m would have been a change in y over a change in x, which in other words is a change in p over change in q. Okay, so change in p, a change in p of 1 results in a change of q of 2. Okay, so m is a half. Okay, that's your m. Right, so now we've got that. Right, that'll be a half. Okay, because its price, 1 rand increase. Okay, we didn't put a plus here. A 1 rand, a plus 1. Okay, demand decreases by 2, a minus 2. Okay, I've put the arrows here. So it'll be a plus 1 and a minus 2 gives you minus a half. Okay, so looking at this, that equation looks good. We need to check the y-intercept. So how do I check the y-intercept? Well, I need to solve for it. Okay, so let's move up a bit. Okay, so now I've got y, okay, which we know is 45. Okay, so y equals mx plus c, y equals mx plus c. If I rearrange this, it'll be p equals mq plus c. Okay, so the price was 45 equals, the m was minus a half, open brackets, the q was 80, close brackets, plus c. Okay, then just solve for c. Alright, so let's check. 80 times negative 0.5 is minus 40. Minus 40 goes to the left, becomes plus 40. So plus 40 plus 45, 40 plus 45 gives you 85. Okay, gives you 85 here. Right, so looking at that, this equation would actually be none of the above. Okay, because question 3 has 130. That wouldn't be correct. Okay, let's just double check just to make sure we've got the correct answer. Okay, so we've got here when the price per lunch is 45. So when price equals 45, quantity equals the demand for 80 lunches. Okay, so 80 lunches. Right, it is known that for each 1 rand increase in price, okay, so P plus 1, Q would be plus, not plus, minus 2. Okay, demand decreases by 2 lunches. Find the demand function and quantity, Q as a function of, quantity Q rather, as a function of price P. Okay, which is what we had. Okay, so obviously, if we relate what we had earlier, okay, P is going to be my quantity, all right, and my, P is going to be my Y, okay. Price is the y-axis, quantity is the x-axis. Okay, so price is the y and quantity is the x. Okay, so change in y over a change in x is going to equal, change in y is plus 1 over minus 2, which gives you minus a half. Yeah, that's definitely correct. Okay, so we double checked it, that's fine. Right, and then I'm looking at the equation. Okay, so obviously y equals mx plus c. Okay, y here is the p, so mq plus c. All right, we said the price was 45, so 45 equals m, which is negative 1 over 2, times quantity, which is 80, close brackets, plus c. Alright, so that's 45 equals minus a half, which is minus 40, plus c. Yeah, we get the same answer. Okay, 85 equals c. Alright, so for this particular question, for question 14, I would be choosing none of the above here. Right, because you don't have that particular option. Okay, none of the above. Alright, question 15, guys. I think this is the last question. Yeah, okay, the last question. Suppose you have a supply function. Alright, so the supply function is P equals C plus D Q. Okay, that's what we've got. Alright, so P equals C plus DQ. Okay, so demand, well, the D is the variables here that we've got. Okay, so there's the function P equals 30. P equals, let's write that down, P equals 30 plus 0.5 Q. Okay, they say determine the arc price elasticity of supply if the price increases from that to that, from 10 to 20. What does this mean? Okay, so that's what we're looking at here. Okay, so when looking at the price, the arc price elasticity, Okay, if you look at the textbook, I've put a reference here, see the formula on page 90. You'll see they talk about arc price elasticity of demand, not arc price elasticity of supply. Right, so I do think there is a typo here in the actual assignment, because this should have been price elasticity of demand and not price elasticity of supply. Okay, because I've done a few workings here to show you what it would work out to. Okay, so if I'm looking at this equation, there's the equation for the elasticity of supply, okay, which is 1 over d times p over q. Right, and then obviously I'm looking at the equation here. Okay, so we had two p's here. We had p as 10 and we had p as 20. Right, so there's the first scenario. That's scenario 1. Okay, and then you had scenario 2. Okay, so scenario 2 was looking at when price was 10, and scenario 1 was looking at when price was 10, scenario 2 was looking at when price is 20. That came from the question. Okay, there's the 10, there's the 20. Right, so now what am I going to do? I'm going to have to solve. Okay, so if I'm solving for Q, I get Q here as minus 40 when P is 10, and I get Q here as minus 20 when P is 10. Right, so what points do I then have? Well, I have quantity and I have price. Here I have quantity and I have price. Okay, so if I'm looking at D, D is the slope of the graph. Okay, so I need to find the slope. If I work out the slope, it's a change in y over change in x, okay, which is what I've got here. So D comes out to 0.5. Okay, then if I take 0.5, which is now the value of D, and I'm substituting D into the equation that I had here at the beginning. ES equals 1 over D times P over Q. Right, I get these answers. I get ES as minus 0.5, and I get ES of minus 2. Okay, if I look at their workings, okay, right, here we're looking at ES. But I don't have ES as minus 5 and ES as Q. Okay, so I think there is a problem with the way this question is worded, right, because they should be maybe looking at price elasticity of demand. Okay, if the price increases from 10 to 20, what does this mean? Okay, so if we're just trying to understand this from a, let's say, economics point of view, determine the arc price elasticity of demand. Elasticity of demand meaning how will supply change, okay, if price had to change. So if price had to increase from 10 Rand to 20 Rand, would people be more inclined to supply or less inclined to supply? They'd obviously supply more because the prices have gone up, so they'd be able to sell more. Okay, so if I'm looking at the actual function, which is P equals 30 plus 0.5 Q, okay, they said here, okay, ES, 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 and ES, okay, while P is within, okay, price is between 10 and 20, supply decreases by 1% for each 1% increase in price. Supply increases, okay, supply decreases by 25% for each 1% increase in price, okay, or supply increases by 0.5% or 1% increase in price. Okay, so they're looking at the change, okay, the change in supply. Okay, so if I had to do a working here, okay, we've already done 2. Those were the price elasticities of demand that I've got. They're negative. Okay, so looking at this, I would be happy to go with either 1, okay, or 3 based on that. Okay, but you can see those answers aren't exact, which is a problem. Okay, because here you're looking at a scope between those two values. Right, supply decreased by 1% for each 1% increase in price. Okay, that's a change in supply, so a change in Q, the quantity, okay, in line with the change in price. Okay, so you can see that the ES here would be minus 0.5 or minus 2. Okay, and those aren't one of the answers. So what I'm going to do now is I'm going to show you the arc price elasticity of demand calculation, which does have a formula. The ED is a change in Q over a change in P times P1 plus P2 over Q1 plus Q2. So if I go back to the question, okay, you've got price increases from 10 to 20. Okay, so we had that earlier. There's it, price from 10 to 20. Okay, so this was the P1. Okay, and that was the P2. Alright, so we need those points. Okay, so if I'm looking at the ED will be a change in Q over a change in P. Okay, so I'm obviously looking at price times quantity. Remember, price was 10 here. Okay, so we're looking at Q here and P. That's what we're looking at. Okay, let's move this down a bit so you can see the working. Alright, so that's what we've got. Alright, so ED would equal a change in quantity, which is minus 20, okay, minus brackets a minus 40, close brackets, divided by a change in price. Change in price is 20 minus 10, close brackets. Okay, then multiply that by open brackets. P1 plus P2, so P1 is 20 plus, 10 plus 20. Okay, 10 plus 20. Right, close brackets. Divide by open brackets Q1, which is brackets minus 40, plus a minus is a minus, so minus 20, close brackets. Okay, equals. Alright, so if I substitute all of that into the calculator, I get minus 1. Alright, and you can see that is an answer to one of the questions. Okay, ED here is minus 1. Alright, so looking at the options, okay, remember ES here was that, okay, those two options. Alright, here ED is minus 1. Okay, so coming back to the question, I'll be going with option 1 here being the correct answer. Okay, because as I said, I do think there's a problem here with the wording in the question. It should have been price elasticity of demand, not price elasticity of supply. Okay, because if you look at the textbook, there is no equation for the arc price elasticity of supply, only a measure for the demand, arc price elasticity of demand. Okay, so please bear that in mind when submitting this assignment, and that's the last question. Okay, so please check maybe online on the discussion forum. There might be a note there about errata perhaps, and that could be a possible errata that they might have posted. Okay, so I would go with number 1 here being minus 1, which is a value that we can solve for. And that's the end of assignment 1.